Flourishing Fully podcast here. It's Dr. Sally. Today I'm so pleased to have Dr. Lee No with us. He is author of Life, the epic story of our mitochondria. It's a brilliant book. Dr. Lee is a naturopathic doctor. He is a consultant for natural health products, and he's written this incredible book that deals with my passion, the mitochondria. So without further ado, let's just dive in. I'm so excited to have you here today, Lee. Welcome.
Thank you, Dr. Sally. My pleasure.
How did you get interested in the mitochondria?
That's an excellent place to start because my passion, just like yours, is the mitochondria, the whole reason I wrote this book. But it was never like that until a few years ago. I mean, we've all learned about the mitochondria in high school biology where we learned about it as this powerhouse of the cell. And I think that's where most people's knowledge of the mitochondria ends. And even coming from a medical background and going through my undergrad with a heavy science focus, we were never really taught the actual importance of the mitochondria to overall health, longevity, and disease. And it was just fortunate for me that a number of years ago I started consulting for a well-known brand in Canada whose primary product was coenzyme Q10. And this company actually sold quite a bit of coenzyme Q10 to a number of hospitals across Canada who were specifically dealing with mitochondrial disease. And you would think that, being in a company like that, I would have developed some sort of appreciation for CoQ10 and the mitochondria, but it wasn't even that triggered my interest. A few years ago, a number of fertility clinics across Canada started to investigate the use of CoQ10 for their female patients who were experiencing, I guess, more specifically age-related infertility. As the awareness around the benefit of CoQ10 in the fertility industry increased, they started to look at different brands and what brands had good products. Fortunately, they came to me and figured, this is a brand that we want to recommend, but they didn't really know why they need to be recommending CoQ10. So they just heard about the value of CoQ10 for their infertile female patients, but they wanted me to come in and do a presentation to their doctors and their nurses to help explain and clarify the role of CoQ10. So it was at that point where I started really doing a lot of research to put this presentation together, where I really developed a passion for the mitochondria. And that's when you look at, and I devote quite a large chunk of my book to infertility because this is fascinating stuff. And in fact, when you look at the eggs or the oocytes, quite different in their mitochondrial content compared to the rest of the cells in the body. And one of the reasons why things like CoQ10 has been shown to, at least in animal studies, be quite powerful in treatment.
Well, that's a great story. So let's talk a little bit about what do the mitochondria actually do. You write that they have a good side and a dark side.
Yeah, so as I mentioned earlier, and as most people will have learned about it, it is a powerhouse of the cell. But understanding why that's important is going to shed a lot of light as to why we want to keep this part of the cell healthy. So when we consider that over 90% of the energy produced in every cell really comes from the mitochondria, and when you also consider that literally everything that happens in the cell, from the basic things like muscle contraction to the really obscure things that a lot of people won't even think happens in a cell, the transfer of ions across cell membranes or membranes organelles, or the maintenance of the cytoskeleton, which gives cells their shape. All these processes take energy. And again, considering that the mitochondria is responsible for the vast majority of that energy in the cell, you can see that organelle, the mitochondria, is important for keeping everything else in the cell running smoothly. So the problem is, and that's the bright side, and as long as everything's working well, there are no issues. The dark side of the mitochondria comes into play when the energy production starts to fall off. And that happens when the mitochondria get damaged. It's not able to produce the energy that our cells need. And without that energy, the cell's not able to function properly. And that's the start of degenerative diseases. So when we look at the newest research across many different health conditions, we start to see that there is a commonality among these diseases, and that's mitochondrial dysfunction.
The mitochondrial dysfunction comes from free radicals, is that right?
That's right. So free radicals, I think most of your listeners will have heard of that term. Typically they're seen as harmful substances. Now I don't want to, get into a debate whether or not free radicals are good or bad, and I do mention some of the benefits of free radicals in my book, but let's just assume for the purposes of this podcast that, free radicals are bad, and simply because they damage the mitochondria. And what's interesting to learn is that the mitochondria is the primary source of free radical generation. This is where free radicals have the most detrimental effects. So when we think of free radicals, we can look at exogenous sources, so the free radicals that come into our body from outside sources, or endogenous sources, so the free radicals that are produced within our body. And when it comes to endogenous sources of free radicals, the mitochondria is the primary site. One of the reasons why maintaining healthy mitochondria by quenching those free radicals, a smart therapeutic approach.
Just as a diversion, the exogenous source of free radicals would be like EMF. Can you mention some?
Right. We're exposed to toxins constantly throughout the day, whether it's through air pollution, the water we drink, the pesticides on our foods. Those are all sources of toxins that create free radicals. And then there are, a number of drugs, as an example, medications that have been known to increase free radical production at the level of the mitochondria. So there are, the list goes on in terms of exogenous sources of free radicals. The interesting thing to note is that the vast majority of these exogenous free radicals actually have very little impact at the level of the mitochondria. So they might induce some damage at cell surfaces, things like that, but very few of them have the ability to inflict damage to the mitochondria, but like I said, very, very important to keep mitochondria functioning smoothly. But when we look at the sources of those free radicals that damage the mitochondria, it actually comes from the mitochondria itself.
Right. Are there free radicals? Are some free radicals worse than other free radicals?
Well, yes, and there are many different types of free radicals. The predominant ones in the mitochondria are based on either oxygen or nitrogen. And when we look at the vast bulk of free radicals within the mitochondria are actually oxygen-based, or what we call superoxide. And because they are produced in the very vicinity of where the DNA within the mitochondria is located, you can look at oxygen-based free radicals, at least within the mitochondria, as being the most detrimental to health.
Okay. Do we have to know or understand the complex reactions of cellular respiration to understand what's going on in the mitochondria?
I think listeners that are maybe a little bit more well-read in this topic, going into the chemistry and the details would be of benefit. But I think I've come across this many times, is when I start talking at that level, we might lose a few people. So it's just to simplify, I guess, we just need to know that oxygen. So let's maybe just give a very, very simple overview of how energy production works. So every time we take a breath in, we breathe oxygen. And that oxygen, really, its purpose is to make its way down to the level of the cell. So the vascular system, the lungs, everything is there to help bring that oxygen in our atmosphere down to each individual cell. And from there, it goes into the individual mitochondria. Now, that oxygen participates in the end process of energy production. So energy production happens in three main phases within the cell. So the first phase, which accounts for maybe up to 10% of the energy that we find in the cells, doesn't even take place in the mitochondria. It takes place in the fluid part of the cell that we call the cytosol, and it's called glycolysis. And basically what we're doing is we're taking glucose and breaking it down into different components. And we get a little bit of energy from that process, but then the end result, or the compounds produced by glycolysis, then enter the mitochondria and gets to participate in the second phase of energy production. And most people have probably learned it as the Krebs cycle, or I call it the tricarboxylic acid cycle, or the TCA cycle. And again, we produce a little bit of energy there, and that happens in the mitochondria, but where the vast bulk of it is produced is in the third phase of energy production, which we call oxidative phosphorylation. And that happens in the electron transport chain. Again, maybe something that you remember from high school biology, but the electron transport chain does is it takes electrons and passes it down a series of proteins. And in the end, that electron is complexed to that oxygen that we breathed in. And as long as that happens, energy is produced fairly efficiently. The problem is that in a small percentage of cases, those electrons will not actually end up being complexed to oxygen through the enzymatic process that creates water. If those electrons spill out prior to being complex with oxygen, it can actually, in an adverse way, react with oxygen to create superoxide. So depending on where that electron is complexed with oxygen, it can either create water, which is a harmless substance, or a free radical, the superoxide free radical, which could go on to inflict damage.
Don't want our listeners to get overwhelmed by that. We're going to go back to the easier to understand part of the talk. But for people who are interested, that was really succinctly and very clearly defined. Thank you. Well, before we leave the complex, can you tell us about calcium ion channels and the mitochondria?
Right, so the mitochondria is involved, so calcium ion channels are involved in many different aspects of cell physiology, or the way that the cell works. It is involved in signal transmission from nerve cell to nerve cell. It also is involved in maintaining different homeostasis or balance within the cells. And the mitochondria is intricately related to maintaining calcium balance within the cells. So one of the things that we recognize is that sometimes there is an overabundance or not enough calcium in the cells, and sometimes that can be related back to the way that our mitochondria are functioning.
Is that how the endocannabinoid system links up or coupled with the mitochondria?
Yes, and that's a great way to look at it, because at this point, even though, so for your listeners listening, the endocannabinoid system is a signaling system within the body that helps maintain balance or homeostasis within the body. And one of the things that we've noticed is that the way that the mitochondria work and its function is very closely related to the endocannabinoid system. The unfortunate thing is that at this point, there doesn't seem to be a lot of research around this, but in the area of calcium channel regulation, that's where some of the research linking the mitochondria to the endocannabinoid system resides. I fully expect in future years that there's going to be a lot more studies looking at both mitochondrial function and its influence, how it influences or is influenced by the endocannabinoid system. But as you mentioned, at this point, it seems to be related to the way that the endocannabinoid system helps maintain calcium balance within the mitochondria and the cell.
So supporting the endocannabinoid system supports the mitochondria.
That's right. And that's, like I said, it's an area of active research. I fully expect a lot more research to come out in the future, but it is a fascinating area of health research at this point.
Right. Well, while the cannabinoids are an ancient plant, the science of it is still relatively young.
That's right. Yeah. So when we talk about cannabis or marijuana, we're really talking about phytocannabinoids. So cannabinoid molecules that we get from plant source. And I'll also mention that cannabis is not the only source of phytocannabinoids. But then we have the endocannabinoids, which are cannabinoid molecules that our bodies produce. And that's one of the reasons and the discovery of the endocannabinoid system and realizing its importance to human physiology and health, I think is one of the main reasons why we're seeing the whole area of research around cannabis starting to mushroom, because there's just so much that we need to learn, and the endocannabinoid system is showing to be quite important to human health.
I agree. While we're on the topic of supporting the mitochondria, for example, with phytocannabinoids, and you've studied extensively coenzyme Q10, there are a lot of substances that support the mitochondria, but could you give us, I don't know, the top, I don't know, where would you cut it off? The top 7?
Yeah, there is, so you mentioned coenzyme Q10, and I would say that is by far, hands down, the number one nutrient to support mitochondrial function. Actually, I've spoken with one of the main researchers for mitochondrial disease, and he mentioned that coenzyme Q10, and this is a nutrient that he prescribes to all his patients with mitochondrial disease, but he was basically saying that, if it was a drug company or pharmaceutical company that developed coenzyme Q10, it would be worth billions. but because it's a molecule that our bodies produce, it's available in supplemental form, it really hasn't gotten the attention that it deserves. But when it comes to mitochondrial function, CoQ10 is definitely the nutrient that you should consider. There are many others, and to kind of group them, I would say B vitamins are also extremely important. So whether we're talking B1, B2, B3, folate, or B12, all these B vitamins are tremendously important to many aspects of mitochondrial function. So making sure that you get enough B vitamins in general are going to be important. But more specifically, I think a lot of the research is really centered around a specific B vitamin called niacin, or vitamin B3, and there seems to be a lot of promising research around B3 right now as well. Some other nutrients that you can consider there's creatine, which I think a lot of people would associate with bodybuilding supplements, even though that is where a lot of the usage is from a commercial point of view. When you look at physiology and biochemistry, creatine has a tremendous benefit to individuals suffering from mitochondrial disease or mitochondrial dysfunction. D-ribose, I can't believe I didn't mention D-ribose ahead of creatine. D-ribose, incredibly important. Again, one of the nutrients I think is far underrated when it comes to mitochondrial health, and D-ribose is the precursor to ATP. So what I mean by ATP is that is a molecule that is considered the energy currency within the cells. So with D-ribose, it just helps our bodies and our mitochondria produce more ATP, which is tremendously important. As you mentioned, there are a number of other nutrients such as magnesium, zinc, alpha-lipoic acid. L-carnitine is also another one. L-carnitine is another nutrient that our bodies produce, but in certain circumstances, you might want to take that supplementally, and that helps our bodies, or mitochondria, use its primary source of fuel, which is fatty acids. So again, we start to see tremendous benefit to all aspects of health when we take supplemental L-carnitine. To make a long story short, that is a short list of nutrients related to mitochondrial function, but there are a lot of others as well.
How about NAC?
N-acetylcysteine, which is cysteine is a precursor to one of the endogenous antioxidants in our body called glutathione. And glutathione is one of the key antioxidants that quench those free radicals produced within the mitochondria. So cysteine is absolutely critical in many situations where our mitochondria are producing an excessive amount of free radicals that our bodies are not able to quench. So just to give you a real life example, something that you're probably familiar with, maybe not so much your listeners, but acetaminophen, which is one of the most popular over-the-counter painkillers. Basically,
It is Tylenol.
That's right. Yeah, I wasn't sure if I was allowed to mention brand names on your podcast, but Tylenol, the way it causes damage to the body is it creates free radicals, and those free radicals need to be quenched by glutathione. And what happens is that when we have too much Tylenol, the glutathione within our bodies gets used up, and without that glutathione, those free radicals then can go on to inflict all sorts of damage, and that's one of the reasons why Tylenol is responsible for a massive number of cases of liver damage. The treatment for acetaminophen overdose, or in situations where a child might have accidentally taken too much Tylenol, the treatment is actually N-acetylcysteine, and simply because it helps our body produce that glutathione and quench those free radicals again.
Amazing information. We didn't mention the newcomer on the block, PQQ. Where does that fit in?
I should have mentioned PQQ within that list that I mentioned before. PQQ.
This is no criticism. It's just to expose that the list of important nutrients and supplements is quite large, particularly for the mitochondria.
Right, yeah. But PQQ is one of the nutrients that I've been particularly interested in the last few years. As you mentioned, it is a bit of a newcomer. It's not a nutrient that is newly discovered. We've known about PQQ for a number of years, but its importance was not something that we understood until more recently. And PQQ was the first nutrient that had been shown to induce something called mitochondrial biogenesis. So as the term would imply, mitochondrial biogenesis essentially just means that we're creating more mitochondria within the cell. So the more mitochondria you have per cell, the greater amount of energy your body's or that particular cell is able to produce, and with more energy, it just functions better. So PQQ, as I mentioned, was the first nutrient to show that it can induce mitochondrial biogenesis. So the human studies around PQQ at this point have really centered around cognitive function, and the brain and the central nervous system is actually considered at rest the greatest energy sucker within the body. So, of course, if researchers are going to look for any condition that they might want to study that would benefit from PQQ, it would probably be related to the heart or the brain. Like I said, the two most energy intense organs in the body. So in studies on PQQ, we see that by inducing an increase in the number of mitochondria within the brain cells, cognition overall improved significantly. So very, very important, especially when you consider that prior to us seeing this benefit with PQQ, really the only way to induce mitochondrial biogenesis was strenuous exercise. PQQ is a bit of a cheater's way to induce mitochondrial biogenesis without going through some extreme measures.
Very important. And it's found in stardust, right? Does that have any implications?
PQQ has been discovered in interstellar dust. This really, and I'll also mention, I believe, niacin or vitamin B3 as well. This really brings into question, and I think I mentioned this in my book about the origins of life. When we look at, the different types of nutrients that might have been needed to start life on Earth. One of the things that we see is, at least in experimental models, that we need a great redox compound, or a compound that's able to go through cycles of what we call reduction and oxidation. And PQQ is an excellent redox modulator. So if that was planted on Earth through meteors or other interstellar dust, that could have been the catalyst to help spur life on Earth, which is fascinating. It's a totally different topic altogether, but there's a lot of controversy around that as well. But the fact that we found PQQ in interstellar dust raises a lot of interesting questions.
Well, I'm going to raise another interesting question for you. So, we've talked about really the biomolecular aspect of energy and TP production in the mitochondria. But we live in a world of quantum physics now. We're vibrational beings, and these vibrations obviously are energy. How does quantum physics relate to the mitochondria? Do we absorb the energy from the universe and it's commuted to our mitochondria? Do you have an opinion about that?
Definitely an interesting area of study. I'll say that I'm not 100% versed in that area, but just going back to, I think it's the first law of thermodynamics where, energy can't be created or destroyed, only transferred from one form to another. And when you consider that the energy on Earth, all the energy has to come from somewhere else. For the vast majority of the energy or the stored potential energy that's on Earth, whether we're talking energy stored in chemical bonds to the energy stored within food, the vast majority comes from the sun. So, talking about quantum physics, and I don't know if I'm making a suitable link here, but the energy that radiates from the sun is transferred, made into a chemical form of energy that our bodies can then use, that the mitochondria takes and creates usable energy. And this, the physical reality that, again, I don't know if I'm making the appropriate link there, but I believe that there is some deeper connection, mitochondrial function and health, to quantum physics. I just am not able to articulate it.
I didn't mean to put you on the spot. It just happens to be an interest of mine of how things happen so rapidly in the body. And we look to the mitochondria for doing that, but we probably have energy circuits that are perhaps liquid crystals, other forms that we're not identifying yet that the mitochondria participate in.
Absolutely. And I think the general rule, as any scientist or medical professional would confirm, we really don't know a lot. I mean, we all want to talk like we know what we're talking about, but in the end, scientific knowledge or scientific understanding is constantly evolving. One of the reasons why I never discount anything, because it doesn't mean that I'll just use homeopathy as an example because it seems to come up a lot, and there's a lot of controversy around homeopathy from the scientific community, whether it's, it actually works or if it's just placebo. But my take on that is because of our knowledge base is changing so rapidly and our technology is evolving so rapidly, just because we don't have the scientific evidence according to today's tools to explain it, that doesn't necessarily mean, it doesn't work. Really, I think we have to look at the tools that we're using and consider that maybe our tools are not advanced enough to measure things like that. So again, relating it back to our conversation, I truly believe that it's just a matter of time before we're able to explain a lot of these things more succinctly.
You're talking about the homeopathy. Do you know if there are homeopathic substances that act on the mitochondria?
I've come across some in my research. It's not an area that I'm particularly interested in, so I just kind of saw it and I continued on with my research. But I do know that there are certain remedies out there that have been linked back to improving the function of mitochondria. I wouldn't be able to tell you off the top of my head, though.
Very interesting. No, I listen, Lee. You know so much. I'm just dazzled by your knowledge. Which supplements do you take?
So I take coenzyme Q10. Now, coenzyme Q10 is something that as I mentioned, is probably one of the main nutrients for mitochondrial health. And just because I've done all this research around the mitochondria enough to write a book, I'm absolutely convinced that CoQ10, an essential nutrient for anyone that is, say, over the age of, say, their late 20s or early 30s. I also take magnesium. Magnesium is incredibly important for many, many different cellular processes within the cell, but has particularly interesting relationship with mitochondrial health and energy production. And then outside of that, I take, D-ribose occasionally. It's not something that I think is needed on a continual basis, but under certain circumstances it becomes incredibly important. For me, I take it just occasionally as a preventative and to just help my body produce the building blocks of ATP. I take a B vitamin, and outside of that, more related to general health are omega-3 supplements and probiotics.
Great. That's a good kernel of supplements. Let's talk about fertility because that's such a huge topic. How do the mitochondria play a role in fertility?
Right. So, and we're really talking about age-related female infertility because we have to keep in mind that there are many different reasons why a female might have infertility, and many of those are not related back to the mitochondria. But for those women that would have been able to conceive had they been younger, but just having trouble just because of their age, this is where mitochondrial function and targeting mitochondrial health really comes into play. So as most people know by now, the older a woman gets, the less fertile she becomes. So by the time you're in your 30s, you might start to have a more difficult time conceiving and carrying a pregnancy through to birth. And that is because oocytes, or the egg cells, have a tremendous amount of mitochondria per cell. So one oocyte on average will have 100,000 mitochondria. That's a huge number when you consider the cell with the next greatest amount of mitochondria are either the cardiac cells or the neurons or the nerve cells. And these typically will have maybe up to a couple thousand mitochondria. Now, keep in mind, the number of mitochondria per cell is dictated by the metabolic demands or the energy demands within that cell. So when I mentioned the brain cells being one of the biggest energy suckers in our body, well, when you look at the number of mitochondria, about 2,000 per cell, it shows you that it does need a lot of energy. However, oocytes, which are essentially dormant for the vast majority of their life, so really don't have this huge energy demand or consumption, they have 100,000 mitochondria. And this is one of the reasons why I really started this area of research, really piqued my interest in mitochondria, because I just thought there's a disconnect here. Why is a dormant cell that doesn't need to produce a lot of energy, why does it have 100,000 mitochondria? Well, in my research, I came to realize that those mitochondria are just laying around ready to jump into action when conception happens. So when a sperm fertilizes an egg, that becomes a zygote, and from there the cells start to divide. And the interesting thing here is that in the first couple weeks, while the cells divide, the mitochondria do not. In fact, that 100,000 mitochondria actually gets partitioned off with each cell division. So after a couple of weeks of cell division, we're down to about, say, 200 mitochondria per cell. And this is actually one of nature's methods of quality control. So when we're down to about 200 mitochondria per cell, every mitochondria better be pulling its own weight. Otherwise, that particular cell is going to experience a cellular energy deficit and is not going to be able to create the energy it needs to duplicate and divide and continue to grow. And if those mitochondria are not able to supply the energy that it needs because these mitochondria are deficient or defective, the cells decide that this is not a viable being and the pregnancy is aborted. And in fact, when we look at miscarriages, defective mitochondria is considered the primary reason or the most common reason why women experience miscarriage. And again, one of the reasons why the older you get, the more likely women experience miscarriages. But what we found is that by targeting the health of mitochondria and ensuring that the mitochondria are functioning well, are healthy, and able to produce that energy that the cells need, well, then cell division can continue on as normal and we can support the growing fetus throughout gestation.
So it's my impression, and I'm not current in that area, but I don't ever hear anyone who prenatal experience is taking CoQ10. Should that be an important supplement like niacin?
Right. Now, keep in mind, first of all, niacin is a vitamin, so absolutely important. It's something I think everyone needs to be taking. You might be able to get some enough from your diet, depending on how healthy your diet is. Maybe some others will need to take supplemental niacin. But with respect to CoQ10, if you're a younger, healthier individual, really there's no reason to take CoQ10. It only becomes more important the older we get. So our bodies naturally start to turn down its own production of CoQ10 in our late 20s, early 30s. And again, that's one of the reasons why we start to see things like infertility start to creep in once we hit our 30s, and that's because the levels of CoQ10 that our bodies produce slow down. So under normal circumstances, not too much of an issue, but definitely something that should become a bigger consideration the older we get. So for women looking to get pregnant, considering that the prime fertile years are, say, in our 20s, most people probably not need to take CoQ10. It really becomes a supplement that's going to be much more valuable for older women looking to get pregnant. And in my experience, again, talking to these fertility clinics, really that's what they're using it for, is these women that are older, undergoing in vitro fertilization. The use of CoQ10 just helps maintain their eggs in a more youthful state.
Great. Let's go through a couple of different health challenges and see where the mitochondria fit in. Let's look at diabetes.
Sure, yeah. So diabetes, there's a lot of interesting research coming around with mitochondrial function being related to diabetes. And we don't know the exact mechanisms at this point, but many situations of diabetes do seem to have mitochondrial dysfunction at its root. And one of the things that I didn't mention earlier on is that those electrons that create those free radicals in the mitochondria, well, those electrons come from food. So the more calories we consume, essentially what we're talking about is more electrons. And when I talked about glycolysis, the first step of energy production, starting from glucose, that's one of the reasons why sugar consumption or glucose consumption is related to diabetes and mitochondrial dysfunction. And that's because whether we're consuming an excessive amount of calories, which we know is a risk factor for diabetes, or consuming excessive amounts of sugar, which we also know is a risk factor for diabetes, what ends up happening is those electrons will flood the mitochondria. When we do that, there are too many mitochondria for the too many electrons for the mitochondria to handle properly, and those electrons then can go on to be complex with oxygen to create those free radicals. Now, what happens is that if there's an excessive amount of free radicals, the mitochondria are damaged, and as I mentioned, can no longer function properly. Well, it's actually the mitochondria that is actually responsible for burning the fat in our bodies to produce energy. And if the mitochondria are damaged, it can no longer metabolize fat as well. So we start to have fat build up in the cells. And this makes the cells less sensitive to insulin, or what we call insulin resistance. So what this means is that now we need to create more insulin to get the same signal within that cell. And that takes our discussion to the pancreas. So the pancreas is what's responsible for producing that insulin. But anytime we produce any substance, we package it, we secrete it, all those steps take a tremendous amount of energy. One of the reasons why, in general, organs typically have a much higher energy demand and not a higher number of mitochondria per cell than other cells in the body as well. So the pancreas, needing to produce more insulin, has to ramp up its metabolism. And over a period of time, the pancreas with a higher metabolism will start to wear out. It'll start to create more free radicals within its mitochondria. In the end stages of uncontrolled diabetes, we start to see that the pancreas is no longer able to produce the insulin that's required, and you start to see insulin levels fall off and then blood sugar increase. Again, we don't know exactly how it happens, but that's the theorized way of how mitochondrial function is related to diabetes. Probably the explanation that also links certain medications to a higher risk of diabetes, and the one that seems to be getting a lot of media attention and research attention more recently is statins. So you probably know statins as the medications that a large percentage of the population are on, and this is to reduce cholesterol levels. Well, statins have been essentially confirmed now to increase the risk of diabetes. And when you consider that statins block our body's own production of CoQ10, you can see the mitochondria is the link between, say, statins and its potential adverse effects.
Yes, it's shocking, isn't it? Shocking that so many people around in North America and around the world are taking a substance that is detrimental.
Absolutely, right.
We only have a few minutes to spend on each health topic, unfortunately, but let's go to cognitive dysfunction and in particular Alzheimer's.
This is an interesting topic because in recent years, and this is maybe, it was great that we got to talk about diabetes first, because in the last few years, we're starting to see an informal definition of Alzheimer's as type 3 diabetes. I don't know if you've heard of that, but essentially some evidence is suggesting that Alzheimer's is really just insulin resistance in the central nervous system or within the brain. If you've heard of Dr. Mary Newport, she's one of the main doctors or researchers looking into this and trying to spread awareness around taking, I guess, an energetic or mitochondrial approach to Alzheimer's. And the way she targets this is that, you know what, if we have insulin resistance in the brain, and keep in mind that the brain, its primary source of fuel is blood glucose or blood sugar, which is one of the reasons why the body has to keep blood glucose levels within a very narrow range, and that's just to make sure that the brain has a constant supply of energy. Well, if the brain's not able to use that blood glucose, things start to fall apart. Things like memory and all of the other aspects related to Alzheimer's. Well, Dr. Newport has discovered that if you are able to switch the brain's fuel source to something else, everything starts to work again. And the brain has evolved to have access or be able to use an alternative source of fuel, and that's ketone bodies. So if you've heard of ketogenic diets, we're starting to see a resurgence around the interest around ketogenesis and the research around that. But basically what we're looking at is cutting out all carbs and sugars. And when we do this, we cause the body to shift its metabolism, burning sugars as a source of fuel, to burning fats. And as a byproduct of fat burning, these ketones are produced, which then travel to the brain and allow the brain to once again have a source of fuel it can use. And because it's able to start to produce energy again, at least in some case studies, we start to see the symptoms of Alzheimer's essentially disappear. Of course, there are many different other aspects of Alzheimer's that might not be related specifically to insulin resistance, but it does seem to have strong basis behind mitochondrial dysfunction. Interestingly, not to go back to cannabis and the endocannabinoid system, but one of the things that is also being studied quite extensively is the benefit of phytocannabinoids in alleviating symptoms of Alzheimer's. And one of the things that we've seen is that THC and CBD, which are the two main cannabinoids in cannabis, they help the body, the nerve cells, clear out a lot of defective proteins or junk that's building up. And it does so by influencing the function of mitochondria.
Yeah, it's amazing the similarity of effects, for me, a novice, between the mitochondria and the endocannabinoid system. So that's interesting news. That's excellent.
I always found it interesting because there is some good evidence coming out, not necessarily in humans, in animal studies at this point, but linking, the endocannabinoid system and cannabis to an improvement or a reduction in risk of Alzheimer's. And I always found that interesting because cannabis use has always been associated with at least a temporary deficit in short-term memory. So there was always that, how can it cause short-term memory deficits in the short term but reduce the risk of things like Alzheimer's in the long term? Well, the newer research, again, around the mitochondrial function is really shedding the light on the topic.
Right. Well, there's a patent 6630507, I believe, issued to the U.S. government that talks about how phytocannabinoids are a very powerful neuroprotectant, a powerful antioxidant. This all fits together.
Right. No, I wasn't aware that the U.S. there was a patent for that, but you're absolutely right. It's the phytocannabinoids are tremendous neuroprotectant. I'm really happy to see that people's attitudes around cannabis there is changing.
Yeah, immune protectant, bone stimulant. It's an amazing, amazing plant.
Right.
But let's go back and talk about another. How about the eye? I'm trained as an ophthalmic surgeon and I've left that for mitochondria. Talk to me about the mitochondria and glaucoma and the mitochondria perhaps in macular degeneration.
Both situations, there does seem to be some evidence to suggest that mitochondrial dysfunction is implicated in both macular degeneration and glaucoma. One of the things we see with age-related macular degeneration is that there are a lot of free radicals being produced, and of course, this a lot of that comes from free radicals produced through UV light and blue light, and as well as air pollution. But the cells, the retinal cells, interestingly, even more, and I mentioned earlier that the brain and the heart are the two most energy intensive organs in the body. Well, I think when you look at individual cells, and maybe the retina doesn't get the attention it needs just because it's such a small part of the body, as an ophthalmologist, you know how important retinal cells are. It suggested that the retina cells outside of the oocyte are the most densely packed with mitochondria. So again, anytime you have a situation where free radicals are being generated, not only endogenously within the mitochondria, but then you have this onslaught of UV light, blue light, air pollution that your eyes are constantly exposed to, you're going to accelerate the breakdown of those cells and significantly increase your risk of macular degeneration.
Absolutely. How about cancer?
I'm glad you brought that up because it wouldn't really be a complete discussion to talk about mitochondria without at least a brief discussion around cancer. The link between mitochondrial function and cancer is not new. I think this was raised back in the 1920s by a doctor or a researcher named Carl Warburg. And what he noticed was that in cancer cells, the cancer cells shift their metabolism to what we call aerobic glycolysis. So basically, the cancer cells want to use glucose as a fuel for cancer cells. And one of the reasons why cancer cells will send signals to create more blood vessels around because it needs this constant supply of glucose. Fast forward decades, now we're starting to see that, you know what, mitochondria and mitochondrial dysfunction is intricately tied with cancer development because the mitochondria is now also seen as the key or the point where, or the master regulator of cell death. So when a cell is no longer viable or it's defective beyond repair, it's actually the mitochondria that sends that signal to the cell, hey, we need to commit suicide because this cell is not functioning any longer. Well, if the mitochondria are not functioning properly and not able to execute that cellular suicide program, well, defective cells are allowed to persist, grow, and divide, and that is essentially the start of cancer. So we start to see, at least in the pharmaceutical industry and the research community, a lot of emphasis around looking at mitochondria, not only as a marker of cancer, so we can track the progression of cancer by looking at the mitochondria, but therapeutically, I think there are a number of pharmaceutical companies looking to target the mitochondria in cancer therapy. So there's a lot of exciting research around that as well.
What health condition have left out a lot? Or deafness, cardiovascular disease? What would you like to touch on next?
I think cardiovascular disease is always an interesting one just because it affects so many individuals. I talked about, statin medications having negative implications to the health of mitochondria. But one of the things that I think a lot of people would be interested in learning is that when we target mitochondrial function, we can actually reduce the risk, even treat, in many cases, serious cardiovascular conditions like heart failure. There are a number of what we call meta-analyses or systematic reviews, which are, at the top of the pile when we talk about the value of scientific evidence. And it shows that things like CoQ10, because of its ability to improve cellular energy production, is very important in any treatment for things like congestive heart failure. The other thing to keep in mind is that when our bodies are not, our mitochondria are not able to produce the energy it needs, muscles start to tense up. And so in our vascular system, our blood vessels are surrounded by tiny muscles. And again, when our cells are not, or those muscle cells are not able to produce the energy it needs, they remain a little bit more tense. It actually, I think it surprises a lot of people to find out that muscle relaxation biochemically requires a lot more energy than contraction. And the example I use is what happens when we die. When we die, our bodies are not able to produce the energy it needs, and our muscles go into this permanently contracted phase that we call rigor mortis. If we were alive, we would be able to produce the energy it needs to relax. And when we look at blood vessels, as long as we can supply the blood vessels with the energy it needs from properly functioning mitochondria, those blood vessels are able to relax, dilate, and we start to see blood pressure drop. So things like CoQ10, again, can have benefits to blood pressure simply because we're supplying the cells with the energy it needs to function properly and relax properly.
Amazing. Let's finish up with aging. Aging, that's something everybody faces, right?
Right, yeah, there's no escaping aging. And it's a great topic to end on because, again, the newest research is showing that the most accurate evidence-based theory of aging is actually called the mitochondrial theory of aging. And the mitochondrial theory of aging is a modification of the earlier free radical theory of aging, which itself was a modification of the wear and tear theory of aging. So if you're familiar with the different theories of aging, you can kind of put them in order. But basically, the mitochondria theory of aging basically says that it's dysfunctional mitochondria, which is the cause of aging. Over time, as I mentioned, we start to see this leak of free radicals within the mitochondria. And over time, the function of mitochondria deteriorates. And when the cells are not able to produce the energy it needs, things start to fall apart. And as I mentioned earlier on, that really is the start of degenerative disease. And without going into the details, because there are a lot of details around this, and a lot of details that really show why this theory is quite accurate in comparison to, say, some of the older theories like the free radical theory of aging, is that it really is the functioning of mitochondria. So we've seen many different studies that looked at this, and it's not so much the free radicals that are generated, it's not so much any other factor. Really, it's when mitochondria start to dysfunction, everything else starts to fall apart. And that's how aging progresses.
Dr. Lee, what's number one takeaway from our session today?
The number one is take care of your mitochondria. It's so incredibly important to all aspects of health, from the basic things like aging and longevity to specific things like Alzheimer's, cardiovascular disease, neurological conditions, diabetes, and the list goes on. So if anyone is at all concerned with health in general, a great place to start would be to look after the health of your mitochondria.
Right. That's what I say. It's all about the mitochondria.
Right.
Well, thank you so much. It's been such an awesome hour with you. We learned so much, and we'll definitely look forward to maybe delving into other areas of the mitochondria with you in the future. But for now, thank you so much.
Absolutely. Thank you so much for having me on your show. It was an absolute pleasure, and I would be happy to come back on at a later date.